Right, guys, welcome back. So that is the second part of our logical database design lecture, where we will learn how to transform conceptual data model or entity relationship diagram into the relations or logical database design. So let me minimize the video and we're gonna get straight to the lecture. All right, so um, you can see a table now on your screen. So those are the rules that we will be using to translate our ERDs into the logical design. So logical database creation of logical database design is pretty simple. We don't need to analyze a lot. We don't need to make a lot of assumptions. Whether remember how we did during entity relationship creation of entity relationship diagrams, where we had to think whether relationship optional, mandatory, where we have to translate those words or business rules into the diagrams here. There is a very well-defined process on how we convert conceptual data model into logical design. And those are the rules. So there are very certain specific rules that applies to every block or every part of entity relationship diagram. So we have a way to convert regular entity, composite attribute, multi-valued attribute, weak entity, binary relationship, unary relationship, and so forth. So what we will be doing now, we're gonna look at the examples of each. So we're going to start from the regular entity, and then we will go down to how to translate subtype and supertype. And once we're done that, and we'll have a couple of examples for each one of those. And at the end of the lecture, you will have examples of how to translate each. And then you go to modules, logical database design in Canvas. And there is an exercise on how to translate one of the existing diagrams in that we did as part of the homework one into the logical design. So there's a practice for you today during the class, and there's also a practice exercise posted in Canvas modules for you guys to practice before you start working on the logical design for the homework. Also, logical creation of logical design is going to be an exam. So please practice, please study, and make sure that you understand this concept really good. This concept is simple, but similar to entity relationship diagrams, it requires a lot of attention. So you need to make sure that you follow the rules and you don't miss any attributes, keys, and stuff like this. So let's start. Well, the way we are going to transform enhanced entity relationship diagrams or regular entity relationship diagrams into the relations, we're gonna have we will need to do as this process, we will need to do several mappings for entities and attributes. So we will be mapping regular entities to the relations. We will be made for mapping attributes. We will have to map simple attributes directly into relation simple attributes. When we'll be talking about composite attributes, we will use one simple attribute for each component attributes. And for multi-valued attributes, we will have to create a separate relation where we will need to create a foreign key and primary key and connect this second relation into the main relations that contains multi-valued attributes. So for weak entities, we will be creating a separate relation with composite primary key, and that is the first part of this second part of the class. So let's look at those 5 examples, and then we will move into mapping relationship. All right, so talking about regular entity, we have our rule table here. We have a simple regular entity customer with 4 attributes: customer ID, customer name, address, and the postal code, where customer ID is a primary key. So customer is a regular entity, so we find the regular entity rule, and it says create a relation with the primary key and non-key attributes like this. So here we have a customer relation, pretty much a set of 4 boxes, and with one underlined attribute customer ID, which is a primary key. We also put name of the relation on the top. So as you can see here, we have a customer word on the top, and then we have a little box for each attribute. And primary key of the relation is underlined. So in this case, customer ID. Pretty simple, right? So let's look at composite attribute. So same customer entity, but address is a composite attribute that has 4 components attributes: street, city, state, and postal code. So we find a composite attribute in the rules, and it says that for composite attributes, we create we create an attribute for each component of a composite attribute. So in this case, we will have a customer relations with a separate attribute for each part of the address attribute. So as you can see here, we have a customer ID, same also primary key, customer name, customer street, city, state, and postal codes. All of those are separate attributes in the customer relations. So again, for the composite attribute, we will create a separate attribute for each component attribute of the composite attribute. Okay, so in our case, address has 4 component attributes. So that would be a logical design for customer relations with a composite attribute. Now we have employee relation with multi-valued attribute. For multi-valued attribute, we need to create a separate relation for multi-valued attribute with composite primary key, including the primary key of the entity. So what is a composite primary key? Composite primary key is a primary key that consists of one or more columns or one or more attributes. So we have an employee here with employee ID, primary key, employee name, and address. Those are simple attributes. And we have a skills. Skills is a multi-valued attribute. So here's how our relations will look. We'll have an employee relation with primary key employee underlined. We also have employee name and employee address. And for employee skills, we have a separate relation with composite primary key. So in this case, employee ID and skill both will be primary keys. Okay, and employee ID at the same time is also going to be a foreign key to an employee relation. So this is a little more complicated concept because one relation is going to turn into 2. But again, based on those rules, we just follow the rules and create what rules tell us to do. So that is how logical design for an entity with a composite attribute is going to look like. Again, every time, or multi-valued, I'm sorry. So every time we see multi-valued attribute, we are going to have one extra relation. And the primary key for this relation will consist of two fields. Um, one of each is going to be a primary key of the main employee relation. All right, so this is a multi-valued attribute, and let's look at the example of, we already looked at the example of composite attribute. Huh. Okay, so let's look at the relation at the example of mapping weak entities. So we have two entities here, employee and dependent. Employee is a strong entity, has two attributes, employee ID and employee name. Employee ID is a primary key of the employee entity, and we have a dependent entity. Dependent entity has a dependent name, which is a composite attribute, right? Because it has first name and middle name and last name. It consists of three component attributes. It also has date of birth and gender. So let's look at our cheat sheet table and see how we convert weak entity. It says for the weak entity, we create a relation with a composite primary key, which includes primary key of the entity of the main entity and non-key attributes. So first of all, we create one relation for the main entity, which is employer. Right, and here on the bottom, you can see that employee relation has two attributes, employee ID and employee name. And dependent relation, pay attention on dependent name. Dependent name is not there. Why? Because dependent name is a composite attribute. And if we remember that for the composite attribute, we create a separate attribute for each component attribute of the composite attribute. And components will be, in our case, first name, middle initial, and last name. So and in this case, we add employee ID foreign key into a weak entity, and this foreign key is going to have a relationship to the employee ID primary key on the main employee relation. Important to understand that arrow is always goes from the foreign key to primary key. In other words, from many side of relation to one side of relationship. So in this case, if you can look at the diagram above, if, on the employee side, employee is one side of relationship, and one employee can have many dependents, and dependent is many side of relationship. We have a crow's foot here on the dependent side. So when we add this employee ID to the dependent relation, we draw the arrow from foreign key to primary key. Okay, right. And in this case, first name, middle initial, last name, and employee ID is going to be a composite primary key for this dependent relation, right? And employee ID, which is part of the composite primary key, is also going to be a foreign key to an employee relation. Right. So let's do an example here. We have a product entity that has total of 5 attributes. One of those attribute is a multi-valued attribute, and one is a composite attribute. I want you guys to think about it and maybe draw a little logical design for this solution, and then we will talk about solution in a moment. All right. So we have here we have a composite attribute. And for the composite attribute, as we know, composite attribute is dimensions. So for a composite attribute, we know that we need to create a separate attribute for each part or each component of this composite attribute. So we are going to have a separate attribute for length, width, and height. For multi-valued attribute type, we need to create a separate relation. So as a result, here we are going to have two relations, right? Product and product type. So product relation will have a product ID as a primary key, product name and description, and it's also going to have three extra attributes, components of composite attribute, length, width, and height. And then we have a separate relation for product type, which will have a product ID and type, and product ID is also going to be a foreign key to a product relation. And as you can see here, arrow goes from the primary key to from the foreign key to primary key. And product ID and type are also going to be a composite primary key of product type relation. All right. Let's look at another example. Let's try to map entity with attributes. So in this case, we have a customer entity and order entity. Order entity is a weak entity because it depends on customer ID, right? It cannot exist without customer ID, so order needs a customer. So look at this example and think about the rules that you're going to apply to that. And pause the video for a second, and then I'm going to explain you guys a solution. All right. So looking at the rules, we are going to apply rules for weak entity, and rule for the weak entity states that we need to create a relation with a composite primary key to which includes primary key and non-key attributes. So in this case, we will have a separate relation for customer, right? Which is customer ID, first name, last name, and customer discount. That's simple. That's a regular entity. For the order entity, we are going to have an order ID, order status, date, and then for the composite attribute order address, we will have separate attributes for each component. And also, we will have a customer ID added to an order table, which will be a foreign key in the order table, but it will reference customer ID in the customer table. All right. Let's look at another example. We have similar situation like last time, but we also have multi-valued attributes, component attributes, composite attributes, and so forth. So there's multiple rules apply here. Right. And solution for that. Well, first of all, how many entities do you guys think, how many relations do you guys think we're going to have here? Okay, so we're going to have three relations. Why? We're going to have one for invoice line, right? But also, since we have multi-valued attributes payment method, we are going to have a separate relation for that. So the result is going to be invoice line relation that has a primary key of invoice number and line number. We're also going to have an invoice relation with invoice number as a primary key. And please note date, time, parts of composite attribute. And we are also going to have a separate relation for payment method that will have a composite primary key, and invoice number will be also a foreign key to the invoice number. Right. So we talked about basic concepts. So now let's talk about a little more complicated concept. Let's talk about how to map relationship. So in entity relationship diagrams, we have three types of relationship: one to one to many, and many to many. And for each of those cases, we have a way to rules to how to convert those into relations. So for one to many relationship, it's pretty simple. We have a primary key on one side, which will reference to a foreign key on the many side. If we don't have foreign key as part of our diagram, we add it. If we have it, great. Uh, Now, many-to-many relationship, we cannot map in the relational data model. So we need to create a new relation in the middle that helps us to control or to manage relationship as one-to-many to one-to-many. So we are going to have one relation in the middle to replace many-to-many relationship. And one-to-one, it's pretty simple. So we put primary key on the mandatory side of relationship and foreign key on the optional side of relationship. All right. So let's look at the example. Customer and order. We have one-to-many relationship. One customer can have many orders. So we're going to find the rule for that. And the rule for that is going to be binary or unary one-to-many. We need to place a primary key of the entity on one side of the relationship as a foreign key on the many side. So this entity relationship diagram will look like this in the logical design. Also pretty simple. We have two relations: customer with primary key, customer ID, and order. So we just need to add a foreign key onto the many side of relationship. Again, as you can see here, customer ID doesn't exist in order entity, but as part of logical design, we add this attribute to make sure that we can connect customer to order in the database, to make sure that we will create this link. Okay, let's look at the example. Important part. So no value in the foreign key. This is because mandatory minimum cardinality. So we cannot have null values here because if you look at the customer side as a relationship between order to a customer, it's mandatory one. So customer cannot be null. If it would be optional, customer could be null. But in this case, since it's mandatory, it's not null. Very important for your group project. All right, so here's an example on how to map many-to-many relationship. Again, we looked at this example before, but in this case, we have a date completed, which is attribute on relationship between employee and course. And relationship between employee and course is many-to-many. So we find the rule here, and the rule states that we need to create a relation with a composite primary key using primary keys of the related entities. This is very important part. Remember, guys, when you ask me many times, should I create an attribute on the relationship, or should I create associative entity here? Does it matter what I do? Remember, I told you that it doesn't really matter what you choose, because during logical design, all your many-to-many relations will turn into three relations. So when you have a many-to-many relationship between two entities, you will end up with three relations anyways. So during conceptual design, it doesn't really matter what you put there, attribute on the relationship or associative entity, because again, during the logical design, you will always have to create a link entity relation or association relation between many-to-many relationships in ERD. So in this case, we are going to have a separate relation for employee. We are going to have a separate relation for course. And since it's many-to-many relationship, we are going to create an relation in the middle. In this case, we call it certificate, but it doesn't really matter how you call it as long as the name makes sense. So in this case, we are going to call it certificate, and certificate relation will have composite primary key, which will consist of two fields, employee ID and course ID. Those attributes are part of the composite primary key, but each of them are also foreign keys to separate relations. So in this case, course ID is a foreign key to course, and employee ID is a foreign key to an employee. All right. So here's another example. Here's another example of mapping a relationship, but in this case, it's a one-to-one relationship. So, for example, in this case, it's nurse care center relations, which is represents one-to-one relationship. So, one nurse can be assigned to one care center, but it's optional. So nurse doesn't have to be assigned to a care center. So let's find this rule for a one-to-one relationship, and it states that we need to place a primary key of either entity in the relation on the other entity. So this case, one-to-one relationship, which is optional on one side and mandatory to another side, will translate in logical design into two relations, nurse and care center. As you can see, we also need to add nurse ID as a foreign key to care center. We can call it nurse ID, we can call it nurse in charge. Why we call it nurse in charge in this case? To bring a meaning into relationships. So it doesn't really matter how you call it, but we call it here nurse in charge ID. And nurse in charge ID is going to be a foreign key to a nurse relationship. And care center also have a primary key, which is center ID. So again, one-to-one relationship will translate into two relations, but into the main relation on the one mandatory side, and then in the relation on the optional side, we add a foreign key to a relation in the mandatory side. So in this case, care center will get a foreign key as nurse ID, or we call it here nurse in charge. Again, please pay attention, and the rows or the arrow is always going from the foreign key to a primary key. Right, so let's look at a couple of examples. We're gonna start from mapping binary one-to-one with attributes, and then we're gonna look at a couple more for many-to-many and for one-to-many. So in this case, I want you to do this example based on what we did before, and I'm gonna explain you how to convert it in a little bit. All right. So Here we have a very interesting scenario. So it's one-to-one relationship. It's binary, right? Because we have two entities, but we don't have an optional relationship, optional side of relationship in this side. So even though we don't have an optional side of relationship, we still know that employee profile depends on employee. So, in this case, we are going to have two separate relations for the employee ID and employee name, but we also add employee ID on the dependent side of relationship. So in this case, it's going to be an employee profile. So even though it's not optional, it still looks like employee profile needs to be related to an employee. So we add employee ID to the profile side. And also attribute on the relationship also goes to the profile side because again it's a one-to-one relationship. It would be if it would be many to many, we would add a separate relation to that. But for one-to-one relationship, even if the attribute is exist, attribute needs to be added to one side, one of the relations. And in this case, we put it in the relations where it makes more sense to put it in. Well, obviously, access level depends on the profile, so we add it to the employee profile. Um, Example of many-to-many relationships. So give it a shot, and I'll explain in a minute how to do it. So again, we have a rule for that, and this rule is stated here. Binary or unary many-to-many relationship create a relation with the primary key associated with associative entity plus any non-key attribute of the associative entity and the primary keys of the related entities as foreign keys. So that's how it's going to look like. So we have author and book. So first of all, we're going to start from author. So author has author ID, first name, last name, and that's it. And remember, for for multi-valued attributes credential, we need to create a separate relation. Call it author credentials. And for author credentials, we are, sorry, let me move it a little bit. Oh, here you go. All right. And for author credentials, we are going to have author ID and credential ID as separate attributes. And both author ID and credential will be a primary key of author credential relationship. So that's will be part of the author side. Then we need to create a relationship for the book. And book will have a separate relation, so with primary key of ISBN and title and genre as attributes. And ISBN, and again, since it's many-to-many relationship, we need to create a separate relation to link those two. And this separate relation will have two attributes. It's going to have ISBN, a foreign key to the book, and it's going to have an author ID, which is going to be foreign key to author. And both of those attributes, ISBN and author ID, will represent a composite primary key of the author book relations. All right. So this is a little more complicated, but again, I mean, if we follow the rules, what we have, we should be able to identify how to map those relationships. So what do we have left? Now we're going to talk about how to map associative entities. There's two different scenarios for associative entities. Um, we can have an associative entity when identifier is assigned. So, well, in this case, we will have a primary key that already exists, and we know what is a primary key. We also have a scenario when identifier is not assigned. So, let's look into two of those scenarios, and we're gonna have rules for each one of them. So first of all, in this case, we have order, uh, product, and order line. And order line is associative entity, but we don't have a unique identifier for order line. So it's still a weak entity, right? So weak entity will have, we will need to create a relation with a composite primary key, which includes primary keys of the other related entities and non-key attributes. So the solution for that case is going to be obviously three relations, one for each entity. We are going to have an order relation with primary key order ID. We are going to have a product relation with product ID as a primary key. But also we are going to have an order line in the middle. And since there is no unique identifier assigned, this order line entity will just have two added attributes, which are going to be foreign keys to product and order, but order ID and product ID will be also a primary key of order line relations. So again, there is no unique identifier exists, so we create a unique identifier. And in this case, unique identifier primary key is going to be a composite primary key. Another example here, we have a shipment entity. But in this case, shipment entity does have a unique identifier. So shipment is a weak entity, but it does have a unique identifier. So this unique identifier is going to be an actual primary key of the shipment entity. So the mapping is going to be very similar to the example that we looked before, with the only difference that shipment and relation will have a primary key that is already defined. And in this case, we just need to add two foreign keys, one to the customer and one to the vendor. Again, the only difference here between this scenario and previous scenario is previous scenario didn't have a defined unique identifier for the associative entity. So we'll have to create it. And when we create it, we create a composite primary key. For this scenario, we already have a primary key defined, so we just need to add foreign keys. All right. So how it's different from the previous slide, primary keys and foreign keys are different fields. So primary key for shipment identifier, and we also have two foreign keys that we add. So again, in this case, those foreign keys are not going to be part of the primary key because we already have a primary key for the shipment entity. So we talked about how to map different attributes. We talked about how to map different types of entities. So let's talk about mapping relationships. So there's two types, actually three types of relationships: one-to-one, one-to-many, and many-to-many. But and we are going to start first from unary relationships. So we have two types of unary relationships: one-to-one and one-to-many, and many-to-many. One-to-many and many-to-many. So there's also one-to-one, but it's a very unique case. So we're not going to spend much. We're not going to spend time on explaining how to do it because it's kind of a sub case of one-to-many. So for one-to-many, we are going to have foreign keys in the same relations. For many-to-many, we are going to have two relations because remember, every time we have many to many, we need to add one more relation. So that is not an exception for unary relationships too. So let's look at one-to-many relations when employee manages other employees. And again, it's one-to-many, so we place a primary key of the entity of the one side into many side as a foreign key. In this case, we are going to have an employee and manager ID. Employee ID is the primary key of the employee relation. So we will add a foreign key, manager ID, to the same relations that will reference primary key employee ID. Okay. So it's kind of recursive foreign key in the same table. All right, so here is the data for that case to give you more content. So in this case, we have an employee 101 who has a manager employee 104. So in this case, Tom with employee ID 104 manages Tim and Blake. Okay, and Blake manages Tina. So Tina has Blake as a manager, and Tom doesn't have a manager. So in this case, we have again, like I mean, in logical design, we're gonna have a manager ID added as a foreign key to the same relations. Um, so, an example of many-to-many unary relationship, a bill of material, when one item can be a component to another item. So, similar to what we had before when we looked into binary relationship. For many-to-many relationship, we need to create a separate relation. Okay, so in this case, we are going to have an item relation, which will look like item number as a primary key into item relation, item description, and item unit cost. So this is this will represent item relation, but we also add a component relation that will have a composite primary key, item number and component number. And in this case, we have a very interesting situation. We have two foreign keys which related to the same item number. Why? Um, because in this case, we have a component part which has its own item number, but it also consists of multiple components which also have their own item numbers. So again, two fields, item number and component number, will reference the same item number in the main item relations. Okay, so we have a composite primary key here, item number and component number, and two foreign keys, item number and component number two, the same actual fields. Here's an example of the same scenario with data to give you a little more content. So, for example, we have item number 102, which consists of multiple components. So, item number 102 has two components, 101 and 105. And item number 103 has two components too. So that item was created out of component parts 104 and 105. Okay, so and 103 needs four 104 component numbers and three 105 components number based on the quantity here. A little more complicated, but so that's kind of like a bill of materials scenario. So you probably seen that in other classes in real life. All right, so let's try an example here of mapping unary relationship. So as usual, just pause the video and we're gonna look at the solution in a few minutes. All right. So here we have unary one-to-many relationships. So we look at binary or unary one-to-many relationships. So where we place the primary key of the entity on one side as a foreign key in the relation of the on the many side. Right, so we have email and we have responses to a specific email. So we have email entity and email number is going to be a primary key here, and response email number is going to be a foreign key. So which is just added, and we added a relation from response email number to the email number as a primary key. Um, so that's pretty much all I have except for subtype and supertype, and subtype and supertype is very simple. So the way we map those is we have one relation for supertype and one for each of the subtypes. So supertype attributes are going to go into supertype relations, subtype attributes will go into each subtype. Important. We will need to add a primary key of the supertype as a primary key of the subtype. Again, not a foreign key, but primary key. And also we will establish one-to-one relationship between supertype and subtype. So here we have an employee, and we have as a supertype, and we have three different subtypes of an employee: hourly, salaried, and consultant. So we look at the table, subtype, supertype. We create a relation for a supertype, which contains primary key for all non-key attributes. And then we add keys here. So in this case, we have four different relations. We have one for a supertype for an employee, right? And the employee number is going to be a primary key here. Then we are going to have an hourly employee, consultant, and salary employed. Very important here. So for every type of subtypes, we are going to add a primary key to each of the subtype, but this primary key is also going to be a foreign key to a supertype primary key. Again, as you can see, we add employee number to each of the subtypes, and we also add specific attributes for each of those subtypes. So in this case, for hourly employee, we add hourly rate, which is a part of the entity relationship diagram. For consultant, we add contract number and billing rate, and so forth. Again, when we have a subtype supertype relationship, we create a relation for each of the element here. So one for supertype and one relation for each subtype. And for the subtypes, we add primary keys, which is the same as the primary key of the supertype. So, which is also going to be a foreign key to a supertype. So that's and yes, and here's an explanation. So we have we added C employee number to consultant employee. We added S employee to the salaried employee, and so forth. So again, those attributes are primary keys, but at the same time they're foreign keys. Okay, so that's all I got today. As usual, if you have any questions, please let me know. I hope you guys are making good progress with homework too. We're going to have an extra credit assignment pretty soon to submit your progress and homework too. And again, if you have any questions, you have my contact number. I'll be happy to answer all your questions. So please reach out if you need to. That is it. That is all I have for you guys. And the next week, we are going to have an in-person midterm exam. All right. So let me stop the video.